This lesson we are going to learn something about hydrolysis. What is hydrolysis? You might have come across this in organic chemistry. That is a different one. Here also we have the same name, but it is nothing but reaction of salt with water. Salt and water is called hydrolysis. Now the salt, how do you get a salt? When an acid reacts with a base, you get salt and water. Acid can be anything, hydrochloric acid or sulfuric acid or nitric acid or carbonic acid or oxalic acid, any one of the acid. But when it comes to bases, bases can be of different types. It can be oxide, it can be carbonate, it can be hydrogen carbonate, or it can be hydroxide. If you have hydrogen carbonate and carbonate, your product you will have carbon dioxide. In all these four cases, you will get salt. Now, if you take the salt and if you add water, you will get products. Okay, so that now the salts are all different types. Now, let's see here, ammonium chloride. You can follow the book, it follows that, but it doesn't write that equation properly. It is there, please note that down. It is ammonium chloride. Salts are ionic substance. They are made up of positive and negative ions. So when you put ammonium chloride in water, you must realize it's going to form an acid, which is hydrochloric acid, and it's going to form a base, which is ammonia. So this is a weak base, and this one is a strong acid. When you combine these two, the solution will become acidic. Acidic means the pH is less than 7 and it will have lots of H3O plus ions. But they do not want this equation. They want the equation using ions. So now you see you get a positive ion. Here this is positive and that one is negative. The Cl minus becomes spectator here. It doesn't react. It becomes spectator. When you want a positive ion, work with positive ion. NH4 plus water gives you NH3 plus H3O plus. Okay, because it produces H3O plus, it is acidic. This is the equation that is expected. Normally they give 3 marks for this equation. So make sure that you understand this. This is ammonium chloride. Number 1, we say hydrolysis of ammonium chloride. Now let's go to number 2, hydrolysis of sodium carbonate. Hydrolysis of sodium carbonate. Okay, now when you have sodium carbonate, it is made up of an acid and the base. What is the acid? Carbonic acid. What is the base? Sodium hydroxide. This one is a weak acid. This one is a strong base. When you combine them, the solution is going to become basic. That means what ion is going to be present? Hydroxide ion. And then the pH is greater than 7. Greater than 7. So now, how are we going to write ionic equation for that? Here it produces negative ions. So we start with the negative ions. Please make sure that you understand the valency for this carbonate ion. 2 minus. Plus water gives you 1 proton. These are called proton transfer reaction. Because the proton is going here from H plus to water, NH4 plus to water. Here it goes from water to this one. So what is going to be the reaction? HCO3 minus plus OH minus. So it is basic. There are 2 more examples. What is the third one? Hydrolysis of sodium oxalate. Hydrolysis of number 3. Hydrolysis of sodium oxalate. Na2C2O4. Now, what is the acid here? The acid here is oxalic acid. And what is the base here? Sodium hydroxide. So, your oxalic acid is a weak acid, while sodium hydroxide is a strong base. So strong base, weak acid. What will be the final solution? Basic. That means OH minus. And the pH is greater than 7. So now let's work with this one. So what's going to be the equation? We are going to start with the negative ion. C2O4 2 minus plus 2 water, because it's a diprotic acid. So 2 of them will go there. So it will form H2C2O4 plus what? Maybe 2OH minus. Let's try to balance the equation. How many hydrogen are there? 4. So 2 are here. So it will become 2OH minus. So the solution is going to be basic. There is one more last example that is there. It is sodium ethanoate. I have seen only one out of these 4 that always in the examination. But the first 2 are very, very important. Hydrolysis of sodium ethanoate. Sodium ethanoate. Here, what is going to happen is, can you see that the base is sodium hydroxide and the acid is ethanoic acid. So this one is a weak acid. This one is a strong base. So the final solution is basic with OH minus. So we start with the negative ion because we got the negative ion as the product. So we take the negative ion plus water, gives you ethanoic acid and OH minus. So hydrolysis is the reverse reaction of neutralization. Neutralization produces water. Here water is added. So in what way? Neutralization ionic equation is H plus OH minus gives water. Here the water is going to be used in the salt to split it back into acid and the base. Thank you.